Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today, we are going to look at organic synthesis. The most important topic is the synthetic route. Well, it is possible to make a large number of organic products from a few starting compound and the necessary reagent. When planning a synthetic route, chemists must consider a few important points. The first one is the reagents required to convert one functional group into another. So therefore, it is very important for you to get familiar to every functional group and the reagents and conditions needed. Alright, number 2 is the presence of the other functional group in case they also react. And the third one is the conditions required, the temperature needed, the pressure, and also the catalyst. So you have to be very familiar with all the organic reactions in both AS level and A2 level. Now we are going to look at one example. So how do we convert methylbenzene to 3-amino benzoic acid in a few steps? First of all, we will have to think what is the most important side chain in methylbenzene. Now you look, there is a methyl group. So what is the function? What is the most important reactions in methylbenzene? It could be electrophilic substitutions or oxidations. Now you need to do a comparison with the product. Well, is that possible for you to convert CH3 to a carboxylic acid or a CH3 to an NH2 based on the reactions that you knew of in this chapter? Well, first of all, we will have to recall back the reactions that could happen in the methylbenzene. So there are only two types of reactions that could happen in methylbenzene. The first is the electrophilic substitutions, where we could substitute things in the benzene, but that is impossible for it to get into NH2. So the next thing you have to think of is the free radical substitutions. So is free radical substitutions happen forming this thing? That is not accurate as well. So the only way to explain this to this is the oxidation. So therefore, the first step is conversions of CH3 into COOH. That is the oxidation. So for these oxidations, the reagents that we need, the reagents and conditions that we need is the oxidizing agent, which is the CHEM with dilute H2SO4, and we need to reflux it. Okay, and that you will get a benzoic acid. All right. Next thing we have to consider is that possible for us to get a side chain to this position so that it will eventually convert to NH2? The answer is yes. We could substitute a NO2 over here. Since this is an electron withdrawing group, which is also a third directing group, so therefore this thing will direct whatever electrophile to the third positions. So therefore, the reactions to is the electrophilic substitutions. The reagent and the conditions that we need is the concentrated HNO3 and also the concentrated H2SO4. Well, we need to heat about 55 degrees C, okay, and that you will get and NO2 over here. All right, so from reactions 2 to reactions 3, from this to this, we need a reduction, okay? We need a reducing agent. So this reaction is reduction. The reagents and the conditions that we need is tin, concentrated HCl, and also NaOH as an optional answer. All right, so this is how we synthesize methyl. We synthesize 3-amino benzoic acid from methylbenzene. Well, let us look at these questions. The following chart shows some reactions of ethyl benzene and compounds produced from it. So, from ethyl benzene forming this, the changes is one of the H over here, out of the 2H, turns into Cl. So when the H substituted by halogen, that means it is a free radical substitutions. This is free radical sub. And the reagents that we need is the Cl2 in UV light. Alright, now let's look at the reactions 2. Reactions 2 is from here moving to substitutions of the Br. So this is known as electrophilic substitutions. And to do this, we need bromine with the halogen carrier AlBr3. Okay, and next, reaction 3. Reactions 3, now look at it. There is 3 hidden H over here. Okay, so the reaction has taken away the H and Cl, forming a double bond here. So this reaction is known as elimination. It is one of the subtopic in AS, and the reagents that we need is NaOH, ethanolic reflux. Okay, next will be the reaction 4. Reactions 4 is the substitutions of NO2. Okay, so for this, we will need a concentrated HNO3 and also the concentrated H2SO4. The temperature is about 30 degrees C. Okay, this is known as electrophilic substitution. Okay, whereas for reaction 5 is the changes of ethyl group becomes the carboxylic acid group, and this is oxidation. So for this oxidation, we will need CHEMNO4 with dilute H2SO4 reflux. And for reaction 6, well, reaction 6 is from NO2 becoming NH2. So this is known as reduction, as we have seen in the previous questions. Alright, for this, we will need tin, concentrated HCl, and NaOH as an optional answer. For reaction 7, okay, now this reaction is the diazotization. Okay, for this we need NaNO2 and HCl. The temperature needed is less than 5 degrees C. Alright, and for the last reaction is the coupling reaction. Okay, and that happened when the H over here substitute by this whole thing. Okay, and the thing that we're going to remove is the Cl and the H, and therefore you will get this direction. Alright, you can see this side is this one. The end two will be joining over here with a double bond, and the rest of it will be the same. Alright, that's it.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.